Hi, this is Mrs. Rodolfi, and I'm doing part 3 of the post-test study guide. So we're on number 16 now, learning target. I can identify the type of function from multiple representations. Give an example of what the graph, equation, and a table would look like for each of the following types of functions. Explain how you can tell the type of function based on the different representations. So we're starting with quadratic. So quadratic functions are always in the form ax squared plus bx plus c. So if we gave an example, we could do x squared plus 5x minus 3. They always has an exponent of 2. We also call this a degree, the largest exponent, degree of 2. 2 is the largest exponent. So it can't be like x cubed, that would be a cubic function. So it has to have x squared, which with squared being the largest exponent. All right, in a table. So I would use one that you have in your notes already, but I just made one up myself. So let's say you have 1, 3, 2, 11, 3, 21, 4, 33, and 5, 47. So first we would want to find the first common difference. So I'm going to extend my table. So first common difference, second. So the first from 3 to 11, that's plus 8. From 11 to 21, that is plus 10. From 21 to 33, that's plus 12. From 33 to 47, that's plus 14. Then we want to find the second common difference. From 8 to 10, that's plus 2. 10 to 12, plus 2. 12 to 14. So as long as the second common difference is a constant rate. And then for the graph, I'm just going to draw a quick sketch. It would just have to be in the shape of a parabola, so that U-shaped. It could be positive facing upward, or if you have a negative a value, another type would be like this. That would have a negative a value facing downward. All right, then for the next type of function, exponential. So exponential functions are defined by the equation y equals a times b to the x. So if we're given a real world example, 1 times 5 to the x power, the variable is the exponent. So whatever the variable is, usually it's x, or in t, it's going to be a raised power. For a table, let's say we had 1, 4, 2, 16, 3, 64, 4, 2, 56. It has to have a common ratio, meaning it's multiplying by the same amount each time. So from 4 to 6 times 4, or 4 to 16. 16 times 4 is 64. 64 times 4 is 256. Also, to help you figure out, think of the word ratio. That's a fraction. So if we take take two consecutive numbers and divide them. So like 64 and 256 are consecutive. We would take the second number, 256, divide it by 64, not 16. So if we do that on the calculator, 256 divided by 64, we get 4, which is our common ratio. If we take 16 and 64, those are consecutive, take the second number, divide the first, 64 divided by 16 is 4. So those tell us our common multiplier is 4. 16 divided by 4 is 4. So they're all multiplying by 4. The way this looks on a graph, and these are not relating to each other. These are all different equations in tables and graphs, but the shape it gives that J shape. And think of the word exponential. It's gradual at first, and then it gets exponentially greater, or it increases exponentially or at a faster rate as the x values increase. So J-shaped. All right, and then the last type that we are looking at in this course is linear. So linear is the y equals mx plus b form. And if we make up an equation, y equals 5x minus 6. So it's going to have a degree of 1. So the largest exponent, remember it's like x to the first, so degree of 1, which is the largest exponent. All right, for a table, I used -2, 5, -1, 10, 0, 15, 1, 20, 2, 25. Linear functions have to have a constant rate of change, so each time it's plus 5, plus 5, plus 5. These are adding 1 each time. So remember, it's the change in y divided by the change in x, 5 over 1, 5 over 1 every time. So constant rate of change, constant slope. And then if we were seeing this on a graph, it would be a straight line. Number 17, learning target. I can identify rational and irrational numbers. So using your foldable, define rational. So rational numbers can be represented as fractions. They're also integers, whole numbers, natural numbers. And then they're decimals that repeat and terminate. So some examples would be -3 halves, 0.333 that repeats, 0.8, the square root of 49, the square root of 64. So perfect square roots, they have to equal whole numbers. So like square root of 49 equals 7. Square root of 64 equals 8. -3 halves, -1.5. 6/5, 1.2. So that could be another one. All right, then we have irrational numbers. Cannot be fractions. Cannot be fractions. Non-repeating and non-terminating decimals. Non-terminating means they go on infinitely. So examples would be pi. Pi goes on forever. If I do second and then the caret, there's pi there. Pi goes on forever. It's not repeating. Imperfect square root, so like the square root of 2, that does not repeat, that goes on forever. Or we could even, let's do like the square root of 5, and then we could like write that decimal. 2.236067977 ... All right, so be familiar and be able to identify if it is rational or irrational. All right, last one is team learning target, I can find the joint and relative frequencies of two-way tables. So the following two-way table shows the number of goals scored in each match by 3 football teams throughout January, February, and March. Show all answers as a percentage rounded to the nearest percent. So that's the nearest whole number. All right. So A, find the total number of matches that the Rovers played. What is the marginal relative frequency? So marginal is on the outer parts, the totals. So we're going to need to add a column there and add a row, and let's find the total for Rovers. So if they played 8 games with 0 goals, 3 games with 1 goal, and 7 games with 2 or more, we have to add these all to get together. 8 plus 3 plus 7 is 18. All right. Then it says to find the marginal relative frequency. Well, in order to find the percent of this, we need to find the total of all the different teams. So let's find the total. So 3 plus 8 plus 9 for the city team, 20. And then United, 5 plus 9 plus 4 is 18. Then let's just go across to make sure we have these totals. So 0 goals, there was 8 plus 3 plus 5, that's 16. 1 goal was 3 plus 8 plus 9, that's 20. And 2 or more goals was 7 plus 9 plus 4, 20. Then this total should be these numbers added up across and these numbers added up down. So 18 plus 20 plus 18 equals 56. And then let's make sure these get the same. 16 plus 20 plus 20 is also 56. Just to make sure you added correctly. All right, that is our total all together. So marginal are these totals. Think of the margin, it's the outer parts of the paper. So the margin of this table are the outer parts, the totals. Relative frequency is the percent. So we're going to take, it's asking for the Rovers total matches. There's 18 total matches divided by 56 of all the teams' matches. And then we want to first find the decimal. So we're going to do approximately equal to 18 divided by 56. Let's just write the first 3 decimal places. So that's 0.321. All right. Then we want to convert this to percent. So we're going to multiply by 100. And then we want to round, so it's 32.1%, but we want to round to the nearest whole number. So you're going to look at this 1. If it's between 1 and 4, it stays the same. If it's 5 or greater, then we go up 1. So this 1 tells us to stay the same. This 2 is going to stay the same. So it's about 32%. So that means the total number of matches that the Rovers played was 32% of all the matches, about 32%. All right, B, find the total number of matches where 1 goal was scored by these teams. So we already found all the totals. So 1 goal, there was 20. Divided by the total, 56. So you're always going to divide by this total, 56. Let's do it on the calculator. 20 divided by 56. Let's write the first 3.357. All right. Then we want to look at that third number. 7 tells us that this is going to round up. So this 5 is going to round up to 6. Also, I can convert it right away to percent. So if you just move the decimal place 2 to the right, that's multiplying by 100, 2 decimal places. So that equals about 36%. So the matches where at least 1 goal was scored, there were 36% of the matches with 1 goal scored. All right, the next two are joint relative frequency. Joint is on the inside. So we've been finding the totals. Now the joint is on the inside of the table of City scoring no goals. So we're going to go to City, and we're going to see that they scored 3 matches that had 0 goals, no goals. So we're going to take 3. We still want to divide it by the total, 56. All right, go to your calculator, 3 divided by 56. Let's write the first 3, 0.53. Oh, 0.053. All right, look at that third number. That 3 tells us to stay the same. And then we can move our decimal 2 to the right. So that's about 5%. So about 5% of the matches, City scored no goals. All right, what is the joint relative frequency that United scored 2 or more goals? So we go to United, 2 or more goals was 4, divided by the total 56. 4 divided by 56. Write the first 3 numbers after the decimal, 0.071. Did I do that right? 4 divided by 56. All right, then I want to look at this 1. This 1 tells me to stay the same. Move the decimal 2 to the right, and that's about 7% of the matches that United scored 2 or more goals. Have a great rest of your day. Bye.